Good morning. Okay, guys. I hope you can hear me well. Whoever is watching it online, topic 11 లో topic అడగవా తీసుకొస్తా ఇస్తారా అడిగితే and in the last class what did we talk about? Newton laws. We talked about all the types of forces, right? What are all the types of forces? There are 4 types of forces we talked about: gravitational force, electromagnetic force, strong nuclear and weak nuclear. We don't really talk about strong nuclear and weak nuclear a lot. వాళ్ళు తర్వాత మాట్లాడు అందరికి తెలుగు వచ్చు కదా. సో వీ డోంట్ రియలీ టాక్ అబౌట్ స్ట్రాంగ్ న్యూక్లియర్ అండ్ వీక్ న్యూక్లియర్ ఆ లాట్. అంతగా ఎక్కువగా మాట్లాడడం స్ట్రాంగ్ న్యూక్లియర్ వీక్ న్యూక్లియర్ గురించి. ఇదేంటి ప్రొసీడ్ అయినా సో స్ట్రాంగ్ న్యూక్లియర్ వీక్ న్యూక్లియర్ గురించి మాట్లాడడం. ఎనీ ఫోర్స్ దట్ వీ ఎక్స్పీరియన్స్ ఇన్ అవర్ డైలీ లైఫ్, దే ఆల్ బిలాంగ్ టు either gravitational or electromagnetic, strong nuclear and weak nuclear. That's what we talked about, right? So కొన్ని examples కూడా మాట్లాడుతున్నాం. Weight, what's the example? Which case does it belong to? Weight is gravitational force, simple గా మాట్లాడతారు, right? So all the 4 cases, gravitational ఒకటి, electromagnetic ఒకటి, strong nuclear force and weak nuclear force. These are the forces that we talked about. And we also talked about some examples. Weight, where does it belong? Gravitational. Electromagnetic ante any pushing force or any pulling force. Any pushing force or any pulling force belongs to electromagnetic. And I also gave some examples. Pushing force ante we call this as normal force. Alane pulling force ki best example tension. We talked about that, right? And then what did we talk about? Tension force, normal force tarvata I believe we talked about
free body diagrams,
spring force.
Yeah, then
spring force,
Newton laws kuda maatladeskunnam. First law is nothing but law of inertia. Second law is nothing but F equals to ma. We also talked about 1 or 2 problems, right? So that was also over. Once those problems are over, we talked about free body diagrams. That's what I remember. Free body diagrams and any structure I give you, you're supposed to draw the free body diagram using, చెప్పా కదా, ఐరన్ మ్యాన్ లాగా ఉన్న పార్ట్స్ అన్ని స్ప్లిట్ చేసేసి try to write all the forces individually and try to represent them. So I'll just give, I already gave some questions yesterday, right?
Tensegrity.
so tensegrity.
I asked people to draw the tensegrity diagram also. Tensegrity diagram అని ఒక డయాగ్రామ్ వస్తే మీరు నిన్న లేరు కదా ఆన్లైన్ క్లాస్ లో. సో ఇన్ yesterday's class I talked about free body diagram అంటే I'll just give you a brief idea. And let us just say I have a situation like this where there is ground. On ground there is a block resting. On top of that there is another block resting. How do you draw the free body diagram? అంటే all you need to do is just split the entire system into different bodies. This is the first thing that you should do. Split the entire system into different bodies. Give me a second. I'll try to pin my video. So, split the entire system into different bodies and then write all the forces that are acting on that. So, what are all the forces?
Headphones iskon do this.
Gravitational force, the weight of this. In between these two, there is a normal force. In between this, there is a normal force. And acting on the top, acting on the ipudu, like let us just say I have this thing is hand resting in my hand. There is a force on the duster and there is a force on my hand also. So R into forces happen. That's all. Whatever. Normal force acting on the body, normal force acting on the body. Again, there is another contact here. So normal force acting on the body, normal force acting on the body. Is that clear? Adile em call to cheppandi raasi. Indulo ra వస్తే చెప్పండి. సో నార్మల్ ఫోర్స్ యాక్టింగ్ ఇందులో రా, ఫోన్ లో రా, అక్కడ కాదు, అక్కడ. సో నార్మల్ ఫోర్స్ యాక్టింగ్. సో దిస్ ఈస్ హౌ ఐ డ్రా ఫ్రీ బాడీ డయాగ్రామ్ ఫర్ ఎనీథింగ్. ఓకే, సో I gave this problem already in yesterday's class. నిన్న మీరు కొంతమంది వినలేదు కాబట్టి ఐఎమ్ గివింగ్ యూ అనదర్ ప్రాబ్లం. దీన్ని ఫ్రీ బాడీ డయాగ్రామ్ వేయడానికి ట్రై చేయండి. యూ పీపుల్ మీరే ట్రై టు డ్రా ద ఫ్రీ బాడీ డయాగ్రామ్ ఆఫ్ దిస్.
Excuse me, sir.
Yeah.
Sir, can you speak in English itself? I can't understand Telugu.
Yeah. I'll make sure.
Thank you.
Yes, sir.
I just asked students in the class to draw the free body diagram of this thing also. Okay. Yeah, all you need to do is split the entire system. Ground, this block, and this block. That's all, right? And what are all the forces acting on each and every block? First block, second block, third block, अन्निट में था weight, and then normal force. If you observe one thing clearly, I'm writing normal force onto the body. This body, force is acting onto the body. Force is acting onto the body. For this block, force is acting onto the body. So please remember, normal force always acts onto the body. It is a pushing force. It always acts perpendicular to the surface and it always pushes the body. So you have to put the force always onto the body. Now, after this example, I gave another example yesterday, but I'm going to repeat it anyway. What if a body is hanging? Yeah, we already talked about this yesterday itself. All you have to do is again split the system. This block, the support. Obviously, this has gravitational force acting on it. And there is a force of tension from the rope. Tension always acts away from the body. You see that? That is a free body diagram of that specific diagram. So I'm going to give you another problem. Obviously, you're going to draw the free body diagram of that. Yep, this is the case. How do you draw the free body diagram of this? Guys, give it a try. All you need to do is split the entire system, right? So there is a support and there is this body and there is this body. Okay. So one is weight acting on it. Done. Then tension downward. Now let's start from this string. Okay. For this string, the tension is like here, away from the support, away from the support, away from the body, away from the body. It's clear to see that, right? How I'm writing the directions of tension. Tension is a pulling force. It always acts away from the body. That is to say, I connected two blocks like this, and I'm pulling them. There is tension in between the wires. So, what is the free body diagram? If I ask you, tension away from the body, away from the body. So, the tension force always acts away from the body. The normal force acts always onto the body. I hope this is very clear to you people.
The normal force and tension force both contact at the same time, right, sir?
They can. I just gave a problem like that, and somebody is asking, normal force and tension force both cannot act at the same time. They can, like, take a case like this. The case that I just drew. Let us draw the free body diagram of this. You guys give it a try first of all. I applied some external force also. This is some external force. Try to draw the free body diagram of this. No, don't. Though you don't have to consider frictional force. No, there is no friction.
Got it, sir.
Did somebody get it?
Yes, sir.
Anybody in the class? You have tried, please show it
Yes,
to me.
sir.
No, not all the forces are drawn. That is right, but normal force directions are wrong. Anybody else? No? Alright, give it a try, give it a try. I'll show you what to do. Wait. All you have to do is separate everybody. There is ground, and there is one block here, there is one block here. Is this clear? Okay, guys. Now, what are all the forces
Yes, sir.
acting on it? There is this force acting on it, that's external. There is mg acting, and there is mg acting. There is a ground contact here, and there is a ground contact. So normal force onto the body, onto the ground. Normal force onto the body, onto the ground, and there is one more force that is left. Which force is that?
Tension.
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 This tension force. So it is acting away from the body, acting away from
Away
the
from the body.
Do you understand? Is this clear? It's easy to
Yes.
understand, right? To draw the free body diagram of any body.
Sir.
Okay or not?
Yes.
Yes, sir.
Yes. Now,
Yes.
once this is clear, to draw a free body diagram of any body, this is where we're going to talk about the third law. We're going to talk about the third law, which is every action has an equal and opposite reaction. Now, this statement is very undervalued and properly not put, in my opinion. What it means is, if I put a force, let's just say, who's the weakest in the class? Let's just say there is a very weak guy in the class and there is a very strong guy. Both are pushing each other. There is a very weak guy and there is a very strong guy. Both are pushing each other. Who is pushing with more force?
Strong.
You
guy.
people might say the strong guy is pushing more,
Same force.
but I say they're same. And you might be confused here, but obviously strong guy can push stronger, right? But if only I take the same problem, take two skateboards. Make the weak guy stand on one, make the strong guy stand on the other. Now they try to push each other. Even though strong guy pushes, he'll also go back. The weak guy also goes back, which means on both of them there is a force. Or to put it very simple, here in this case, the ground is applying normal force on the body. The body is applying normal force on the ground. These two are action and reaction pair. These two are action and reaction pair. The ground is putting a force on the body is putting a force on the ground. Those two forces are called as action and reaction. Please try to get this point very clear. Okay. You people might have heard a lot of things like in school, when you hit somebody, they hit you back, so that is action and reaction. No. I mean, practically speaking, that can be considered as like action and reaction. But in physics, in Newtonian physics, that whatever we're talking about right now, no, it is not considered as action and reaction. Okay, what is action and reaction? I try to move this chair. Let us say I'm trying to put some force on the chair. Now, if you people think the force on the chair is action and moving is reaction, no. I'm putting some force on that. The chair is putting some force on me. Obviously, right? Like you can clearly feel the force. So you try to move the wall. Let us say I'm trying to push the wall. The wall is trying to push my hand also. If this is action, this is reaction. If this is action, this is reaction. Is that very clear? So, as long as like to make it even more understandable, let us try this, okay? Let us take a very weak, very weak guy. And he's holding to a wire, and a very strong guy. Strong guy with strong legs, strong hands, and six pack abs. Okay, very strong. Muscles, all great. All cool? Everyone not atla? No? Okay, fine. Vikas, hi Vikas, where is Vikas? Vikas, you have a six pack. Thanks. Now, let us just say, you all know weighing machines, like there are weighing hook, and if you put weight onto that hook, it will show the reading. So there are digital weighing machines also these days. All you need to do is like put, like let's just say you have a bag of 1 kg sugar. All you need to do is you put it on the hook and you show the 1 kg reading. You know the hooks, right? Hook reading. So I'm going to take two of those hook readings. I mean, like 2 meters, 2 digital meters which can measure weight. I'll hook on both the hooks, like this has a hook and this has a hook. I'll connect them like this. Now both of them trying to pull it. Both of them trying to pull it. Obviously, one guy is strong and the other guy is weak. If you believe this and this will show different readings, you are stupid. If this shows 20 kgs of reading, this also shows 20. How is it possible? Because the force he is putting on him and the force he is putting on him are equal. But why is he moving forward? That's a different case. But that is because of friction and all. If there is no friction, you will see a whole different world. Okay, if there is no friction, if you hit somebody, you will also go backwards. Okay, if there is no friction at all. Since there is friction, I can hit you and still stay at the same position. Let's say the chair is here. If only there is no friction in this room on the ground, if I try to push the chair, I'll also go back. You know that? It will happen. In space, let us just say in gravity-free space, in satellite, I try to push a body, I'll go back. Because I try to push with some force, the body is trying to push me back with a force, and that is why it is called as an action and reaction. Not the bag moving forward is a reaction. Okay, please don't try to misunderstand it. I try to push the, let us say there is a huge bag. I'm an astronaut. I'm in space. Okay, I'm floating in a satellite. Now I try to push a body. I try to push a bag, huge bag. The bag also pushed me. So the bag goes that way and I go this way. So this force and that force, the force I put on the bag and the force bag putting on me, they are action and reaction pair. Is this clear? Those two things are called as action and reaction pair. Now, one more important thing about action and reaction. Please remember this. I might ask this question again. Action and reaction never act on the same body. The action and reaction, they always act on the different bodies. If I put action on that, reaction will act on me. I'm pushing the bag or pushing the chair. That is action. Yes. This is reaction. And also it is important that you don't really have to consider this is action, that is reaction. The chair putting the force can be considered action and mine is reaction. You can say that. You don't have to say this is action, this is reaction. You can say this is action, this is reaction also. The important thing is this is acting on the block, this is acting on the ground. You see, they're not acting on the same body. They clearly are not acting on the same body. So this is acting on the block, this is acting on the ground. Is this clear? So let me just take you to a very simpler problem, not this complicated, to make you understand. A very simple problem, no? Let us just say a body resting on the ground. And we draw the free body diagram of that. I can go to this point. Okay. I draw the free body diagram. What are all the forces? Mg,
Mg,
N, and
G.
M.
Yes.
And M. Now you people are about to face a very important problem. Which is action, which is reaction? This normal force is action, this normal force is reaction. Or this is action, this is reaction. Great. We just learned a law. What is that law? Every action has an equal and opposite reaction. This is an action and reaction pair. Everything is great. Where is the reaction for this force? If this is action, where is the reaction? Where is the reaction for Mg? That is my question.
Sir, air resistance, I think.
Shut up. Somebody said air resistance. No. Where is the reaction force for Mg? This is a question that I'm going to leave it like that. I'm not going to answer that. But I can clearly tell you one thing, that this is action and this is reaction. That is for sure. What is the reaction for this? You people have to do some research and tell me later. Not right now. You
Sir,
don't
it
have
is
to.
experienced by the body, sir.
Nope. Somebody says it is experienced by the body.
And
No. What?
normal.
I didn't get you.
He says
Reaction
normal.
for mg.
This is the action force. Where is the reaction? Where is the reaction force acting, and on which body is it acting? Is my question. On this
The
body,
same
gravitational force is acting. Where is the reaction? Remember that reaction must be
On the land. On the land.
the reaction must be
On the body.
equal. Guys, somebody
On the
has
body.
to go mute. Guys, somebody has to go mute. The reaction has to be equal, opposite, and should act on a different body. It must act on a different body. So, you people tell me.
Sir, gravity is
No.
on the body.
Sir, the normal force on the body.
No, please don't say normal force. Please don't bring normal force into this. Normal force and normal
Sir,
force.
MG
These
on
two
the
are an
body,
action and
sir.
reaction pair. These two
Sir,
are an action
MG
and reaction pair.
Gravitational,
What?
gravitational force.
Which gravitational force? Where? Show me.
On the objects.
Are this is the action. You say this is the reaction. What are you, stupid? If this is the action, where is the reaction? That is what I'm asking.
Surface.
Where? I don't see any other force. Somebody says surface. Do you see any other? We need pairs, right? But we have three forces. These two are already a pair. This is single like you people.
Sir,
I
MG
hope.
towards the body, sir.
Single like you are no? Ni parent Jivan. Okay. So this is single like you. Where is the soulmate for this? Where is the partner for this? Just like you people. Where is your partner? It's a big question, I know, but yeah. What about this? Where is the reaction for
Sir,
this?
the surface is acting the force.
What?
The surface is applying some force on the body.
Where? Show me another force, man. Like I see in the entire free body diagram, every time I draw a free body diagram, we draw all the forces in the situation. I already put all the forces in the situation. Where
Sir,
is the
sir.
reaction?
Gravitational force acting on the ground by the object.
Where?
Like mg, it is acting by the ground, and then the object will act in gravitational force on the ground.
You are
It can be
almost
downward.
close. You are almost close. We will discuss that in our.
Sir, MG towards the body, sir.
We will discuss that in the normal classes, not in the bridge course classes. Okay. Now I want to show you. Shit! I almost forgot. The important thing is this mg, this normal force and this normal force are just what? Action and reaction, and they are equal to each other, opposite to each other. They're clearly acting on different bodies. So if you really want to make notes of that, please try to note down a point saying action and reaction always are equal, opposite, and they act on different bodies, never act on the same body. If you want to make notes for that, please make note that. Next question, Jordan. We already have drawn the free body diagram of this thing, but there is something important that you need to learn here according to Newton's third law, which is we already have put mg. For our confirmation, let us call it as m1 and m2. So in that case, it is m1g, it is m2g. When I write normal force, do you remember we used to put n? But now I'm going to put n1 only, right? No, I'm not writing n2. I'm also again writing n1 because That is an action and reaction pair. They must be equal and opposite. N1, N1. Similarly, I write N2, N2.
N2.
So you understand how we applied the Newton's third law to this diagram? We used to write N, 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 N. But now we are making it very clear that these two are equal and these two are equal. Which two are action and reaction pair here? These two are action and reaction pair. These two are action and reaction pair. For now, these two look like very single to us. Don't pair them up. It'll be like pairing up you two people. Do you want to pair up among yourselves? No, right? You want a partner, which is an equal and opposite one, not the same one. Same one వద్దు కదా మీకు కావాలంటే చెప్పరా మాట్లాడదాం లేదు కదా we want an opposite one, right? So that is it. Don't pair them up. This also has reaction, which we will find out. One guy already gave the answer, but we will find out. We will talk about it later. This also has reaction somewhere. This has a reaction somewhere. This has a reaction somewhere. This is action and action only. Is it clear? Now let us talk about this case now. Ready? What is the free body diagram? We already did it.
Tension.
Tension. If this is M1, it is. Which two are action and reaction? Will you people tell me? Action and reaction. Which two?
The tension.
These two are action and reaction pair. Clearly observe, they're equal, opposite to each other. They're not acting on the same body. They're acting on different bodies. So those two are action and reaction. Cool. Where is the reaction for this? God knows. We will know. Maybe in 15 days of time, we will start into that topic and then we'll get into it. But this is clear, right? So every time I draw a free body diagram, you can write all the forces. So if I give a problem like, are you going to give me all the forces? Come on, tell me.
So T1, T2.
M1, M2. So this is M1G,
M2G.
M2G, T1, T1,
T2, T2.
T2, T2. These two are action and reaction pair. These two are action and reaction. So the entire string has a tension of T2. This entire string has a tension of T1. I hope this is very clear to you people why I'm writing all these things like this. So once you know it's already 10:40, I want you to do one thing. I want you people who are also watching. I want you people to draw the free body diagram of some complex structures. Yesterday, in yesterday's class, only you were there. Okay, fine. So I gave a specific diagram. Give that to rest of those people. I gave a 10th integrity diagram. I want you people to draw the free body diagram of that and take random cases like I am standing on the ground. Draw the free body diagram. I am standing on the chair. Draw the free body diagram of that. I am standing on him. Draw the free body diagram. Everybody come back with 3 cases. Try to draw 3 diagrams. 3 cases with free body diagrams. Try to involve normal forces. Try to involve tensions. If you want, try to involve tensions at an angle, forces at an angle, bodies at an angle. I don't know. Like let us just say I gave a case like this. The body is resting in between my hands. The surface is like this. The body is resting, the duster is resting in between. But I do this. I block the duster like this. So I'll try to draw the free body diagram of this. I don't know. You have to come back with 3 cases, 3 interesting cases, where the problems are drawn in terms of free body diagram. Once you are clear with that, I'll give you some problems in tomorrow's class and we will go through that. All right. So I'll just hope rest of the people also come as early as possible and we will start the classes normally. All right, guys. So if you have anything else, you can ask. Otherwise, I'll end the session. Anybody else? Guys, out.
Yesterday I got 4 cases for integrity, sir.
Try to send it to me on WhatsApp or Instagram.
Okay, sir.
Okay. All right, guys. I'm ending the session. We'll meet. Yeah.
Sir, should we come to the new one or to the old building, sir?
Talk to DVS sir or Ravi Kumar sir about it. Okay, I'm not sure where we're supposed to come.